Hello everyone, mic test. Okay, just to give you all a heads up, there's a lot of renovation going on in the surrounding office complexes. So I'll be talking louder for this session. Okay, hello Rasmus, Cindy, Rekha, Terry, Melvin, Jermaine, Barafti Raja, Jais, Rose. Okay, I guess apart from the renovation, everything is good to go. Right, welcome to tonight's Facebook Live session on the unit transfer method mini course. It will be a summation of everything that we've gone through thus far. It will be on differentiating the scenarios. Okay. Hello Stefan, Isin, Jonas, Cherise, Jasmine, James, Emin, Shivani and Esty. Alright, so let me talk a bit about what happened? Yeah, let me talk a bit about myself first. I've been working in Maths Heuristics since 2011 and right now I'm the curriculum specialist here. So I'm very happy to share these things that we've learned and developed over time. And the best part of it is an efficient problem-solving technique that can be applied across several topics. The whole numbers, fractions, decimal, ratio, percentages. And if you go further down the road with me, you will see that it can be applied on number value, total value as well, averages, speed and rate, and even volume. Okay? Can put louder or not? Okay, let me try to talk louder. Yeah, it's going to start soon. Okay, so this entire mini course is founded on the Mastering Heuristics series, which my mentor, Mr. Sunny Tan, has written on several years ago. This was first published in 2008, and after that, a second edition was published in 2010. Okay, it's all based on these ideas that are properly well illustrated and described, okay, in the hard copy format as well as the soft copy format. Okay, so there's a one-shot solution and there's an explanation on the thought processes, how they are derived, so that you can use it to solve these problems. And then we also have these apps as well that we've developed. So the way the app works is that you will see that you have this question here. It is the same exact content as the book. However, we also recognize that children have different ways of learning. So we have created this app to make it interactive and control the flow of information. Okay, you can see that it's step by step in this regard. So I was also involved in that project. I could tell you more about it if you want to know more. Okay, then as you know, we've been conducting this mini course for the last few weeks. On the first lesson, we covered on single unchanged quantities. Second lesson, we covered on different unchanged quantities. Third lesson, we have covered the total unchanged quantities, and lesson 4, we covered the all changing quantities. So now we will sum up everything to share with you how to differentiate these common scenarios and score that A or A star. Okay, now let's get into the lesson proper. So over here there's a bit of, okay, wait, for this portion let me change this back to white screen first, because the color is a bit off, so I'll try to adjust it next time. Okay. Okay, this happens to be the only phone that I have right now. Yeah, okay. Okay, let's just talk about how to identify these scenarios. There's a drilling sound because there's some renovation going on in the surrounding offices. That one I don't really have a control over it. Sorry about that. Okay, so now let's move on to this. Now, in single unchanged quantities, what did we talk about? We say that if A has got $10 and B has got $35, and if A were to spend $3, then A would have $7 remaining, while B would still have $35 remaining. Okay? So, how do we know that this is a single unchanged quantity? We say that inside the change row, at least one item remains unchanged. Okay? So, what about total unchanged quantities? This, some of you may know this as internal transfer, but that is not the only case. Sometimes, when an equal number of items has been replaced by another, total unchanged quantities situation also arises. So let's say that A has got $10 and B has got $35 here. Now if A were to give B $3, A's amount would be decreased by $3, B's amount would be increased by $3. So A would have $7 here and B would have $38 here. If you compare the total amount before and after, before the total amount is $45 and after that the total amount is still $45. So based on this tabulation, how would you know that this is indeed a total unchanged quantity? We say that inside the change row, we have the same numbers with opposite signs. Okay, they can be plus, minus, or minus and plus. Okay, now next one would be on difference unchanged. This one we covered in the second chapter. So let's say that A is now 10 years old and B is now 35 years old. In 3 years' time, both of them must age by 3 years. Okay, there is no way that A can still stay at 10 years old and B ages by 3 years old. Okay, there is no way you can do that. So A will be 13 years old by then, B will be 38 years old in that 3 years' time. So if you compare the difference before, the difference is 35 minus 10 to give you 25. The next difference here is 38 minus 13 to give you 25. Both differences give you $25. Both differences give you 25 years of age. So please take note of one more thing here. The difference in age will always remain unchanged. Okay? So based on this, how do you know from this table that this is indeed a difference unchanged quantity? You see that in your change rule, you have the same numbers with the same signs. Okay, it can be plus plus or minus minus. Okay, please do not spam. Please do not spam too much, okay? So now, on all changing quantities, between A and B, let's say A has got $10 and B has got $35. Now if A were to spend $3 and B were to spend $5, A would have $7 remaining, B would have $30 remaining. Now if you compare their total before and after, before their total was $45. And their total later on became $37. Okay, there was a decrease in their total. Then the difference over here between B and A, 35 minus 10 will give you $25. And the difference after will be 30 minus 7 to give you 23. So there was a decrease of $2 here. How do we know that this is an all changing quantities scenario? You want to look at the change row first. And you will see that you have different numbers. Okay? Okay, please take note of this first. Okay, if you haven't done it already, please wait, let me just show you what's going on. Okay, let me just show you what to do first. Okay, if you're using this mode, please swipe away the comments first so that you can concentrate on the lesson. Okay, can you all see it? You want to swipe away the comments first so that you can concentrate on the lesson itself. Okay? Okay, so let's get back to the lesson proper. Now I will go back to my black screen. Okay, easier on the eyes. I've been staring at the computer since 12 PM this afternoon. Okay, so my eyes need a break. I'm not that rich. Okay, so number one, okay, 5/6 of the cars were owned by Company A and the rest were owned by Company B. Company B bought another 90 cars and now owns 2 out of 3 of all the cars. How many cars does Company A have right now? Okay, to deal with this problem, 5/6 of the cars were owned by Company A. Okay, this means that this is your before. The rest were owned by company B. So this has to be 6 minus 5 to give you 1. Okay, just to be sure, I can you all see the blue color properly on this black? Can Okay, so I think I'll use something a bit lighter so that the contrast is stronger. Now company B bought another 90 cars, that's the change. And now company B owns 2/3 of all the cars. 3 goes to all the cars. This 2 refers to company B's outcome. So how many cars does company A have right now? Now to deal with this, let's draw out the BCA table first. Okay. Company A, company B, before, change, and after. Okay, so company A has got 5, company B has got 1, company B bought 90 cars, now company B has 2, company A would have, okay, take note, all of the cars over here is 3. So the total here is 3, and the company A would only have 1. Okay, so the next thing to do is we say that these two are equal because there is no change for A. Look at the change row first. There is no change for A, hence these two are the repeated identities. We want to make them the same. So I will multiply this by 5 to get this to become 5, and then this will become 10. Okay, so based on this, these two, we can say that these two are equal. We want to make them the same. So over here, so over here we can say that the change in units, why so big? Change in units is 10 units minus 1 unit to give you 9 units. See, from 1 unit you increase up to 10 units. Correct? Then what was the change in value? The change in value was 90. So you can form that connection and say that 9 units is 90. The change in units is equal to the change in value. So once we've got that, we can say that 90 units, 90 cars distributed across 9 units means that 1 unit must have 90 divided by 9 to give you 10. So when we have this already, we need to find out how many cars does company A have now. We're going to find 5 units. So we simply do a multiplication. We have 5 copies of 10, and that will give us 50. So the answer here is 50. Okay? Oh, 10OP1 too easy for you. I like that. I'll be sure to make the challenging problems a lot more challenging. Okay, very good, every one of you. Everyone who has answered 50, very good. Okay, if you got it, please spam the like button. If you haven't got it, please clarify. The last question then a bit hard. Okay. I like that spirit. Okay. Can you let us write on 10OP? I can, but based on how you behave here, I don't think it's going to turn out well. Here you already spam like there's no tomorrow. Okay, thank you all for your feedback. Okay, so let's move on to number 2. Okay, so for this, in case if you want to take notes, this is a single, unchanged quantity question because there is no change for A. Okay. Number 2. Okay, number 2. Alice had $168 and Ben had $88 at first. So after they each spent an equal amount of money, Alice had 5 times as much money as Ben. How much did each of them spend? Okay, Carries, please concentrate. Stop spamming. Now, let's look at the whole situation first. Alice had $168, Ben had $88 at first. This was before anything happened. Each of them spent an equal amount of money. Now, be very, very particular about keywords like this. Equal amount, the same amount, an identical amount, and so on. Then, Alice would now have 5 times as much money as Ben. Okay, allocate units. 5 goes to Alice, 1 goes to Ben. Now, draw out the BCA table according to the situation. We know that. Okay, draw out the thing first. Well, you're so fast. You're so fast. Okay, so now let's input whatever we know first. Okay, if you are done with this, go to example 4 and try it first. So, Alice had 168. Plug that in first. Ben had $88 at first. Plug that in also. Both of them spent an equal amount of money. So, put a minus question mark here, minus question mark here. Alice would now have 5 times as much money as Ben. So this is in terms of units because you would have 5, Alice's amount can be represented as 5 blocks, Ben's amount can be represented as 1 block. So when we have this already, we look at the change row first. And what do we have? We see that we have the same numbers with the same signs. Hence, the difference remains unchanged. Then when your difference is unchanged, okay, yeah, most of you got it already. Okay? We extend out a difference column and then we compare this. So between 168 and 88, the difference before was 168 minus 88 to give you 80. Okay, let's just put that in first. Then the difference after would have to be 168, 5 units minus 1 unit to give you 4 units. So this will give you 4 units here. Then, because your difference remains unchanged, we can form that connection and say that these 4 units must be equal to 80. Okay? So when you have that, you can now say that 1 unit must be 80 divided by 4 to give you 20. Then after that, to find out how much did each of them spend, you want to simplify out all these first. 1 unit here is 20. 5 units here must be 100. So, when you have this already, you can now say that the amount that each of them spent must be this question mark here. Then to find that question mark, it's pretty obvious from here. Before you had $88, at the end of the day you had $20. Then you must have spent. You can look at B's point of view. This will be $68. Okay, and if you want to double confirm that you are indeed correct. Why are that? Hang on. Now, if you want to double confirm that you are, P spend 88 minus 20 will give you $68. The answer here will be $68. Okay, so how do you know that you are indeed correct? You can check your working over here by looking at A's perspective. A spent how much? A spent 168 minus $100 to give you $68. So you would know that you are correct. Okay, of course you can also use border for this. Yeah. The circle is there because of some funny issues on my computer. Okay, so if you got it, please spam the like button. And secondly, when you are done with your number 4, please come back to this. Okay, a lot of you got it. A lot of you got it. Okay, if you are not too sure, please clarify first. If your screen is blurred, please try to refresh it because mine is pretty sharp. Okay. So now, okay, thank you for your feedback. Let's go on to number 3. Okay, please include this. I realized that in the earlier version of the notes, this line was left out. Find the number of stickers that Mary received from Sally if Mary has 132 stickers in the end. Okay, please add this line in. If not, you find that you can't solve this problem. Okay? Okay, so now let's move on. Okay, let me just write this in. Okay, Mary has 20% more stickers than Sally. First things first, whatever you do, you want to simplify the percentages into a fraction first. This will make your problem solving a lot easier. Okay, 20% means that you have 20 blocks out of a total of 100 blocks. And then that simplifies down to 1 out of 5. So let's do that. 1 out of 5. 5 goes to Sally, 1 goes to Mary. The keyword here is more. So Mary would have 5 plus 1 blocks. Then this we know is the change. This we know is the before. After receiving some stickers from Sally, this is the change. Mary now has got thrice as many stickers as Sally. Allocate units, 3 goes to Mary, 1 goes to Sally. Okay? Yeah, you can. So find out the number of stickers Mary received from Sally if Mary has 132 stickers in the end. Okay, so over here, let's draw out the BCA table first. Mary, Sally, before, change, and after. Okay, so now Mary has 6, Sally has 5. Sally gave some stickers to Mary. Now Mary has got 3 times as many stickers as Sally. So over here, look at the change row first. What remains unchanged? Okay. Total. Yes, very good. And how did we get that? We say that over here we have the same numbers with opposite signs. And hence your total remains unchanged. Okay? Very good. I want to give your comment a like also. Yeah. So based on this, your total is now repeated. So we compare that. Now 6 plus 5 will give us 11. 3 plus 1 over here will give us 4. So we say that these two are equal. We want to make them the same. Between 11 and 4, the lowest common multiple is going to be 44. And how do you find your lowest common multiple? If you're not too sure, just list out the multiples of 11, the multiples of 4. Okay, what is the lowest common multiple between two numbers? It is the smallest number that can be divided by both 11 and 4. Okay, without any remainder. So if you're not too sure about this, list out your multiples first. And you'll see that this is the number that can be divisible by 4 as well. So to do this, I have to multiply this by 4, this entire row by 4. Then I'll need to multiply this entire row by 11. Okay? So of course there's another way to do it, but I won't go through that. I will show you this so-called faster way of doing for tonight. The basic way of doing, I've covered it over the last few lessons, so please refer back to that. Okay? So multiply this entire row by 4. This will become 20. And now this becomes 33. And this becomes 11. So when we got all this already, now we want to try to find the value of 1 unit. We want to look for information to find the value of 1 unit. To do this, I can see that Mary has got 132 stickers at the end. This is also the after. So I can say that these 33 units must be this 132. So Mary's units is 33 units, which is also that 132. Okay, So we say that 33 units is 132. Okay, we formed that connection already, and now you can find out the value of 1 unit. That would just simply be 132 divided by 33. Okay, that will give you 4. Then now we need to find out the number of stickers that Mary received from Sally, which is this amount over here. To do that, we can see that the change in units will be from 33 units down to 24 units, so that's 9 units worth. And this change was what Mary received from Sally. So 9 units will simply be 9 copies of 4 to give you 36. So we can say that Mary received 36 stickers from Sally. Okay? Okay, this would be minimally a P5 question because it involves percentages. Alright, but don't worry about it. Don't be intimidated by percentages. Convert it to fractions first and allocate your units. Okay, please refresh first. Okay, very good. So I guess most of you got it. If you got it, please spam the like button before I move on to number 4. Okay, I think most of you got it already, so let's just move on to number 4. Okay, now, okay, there were 4 times as many apples as there were oranges in a box. So this is before. 4 goes to apples, 1 goes to oranges. 60 additional apples and 5 additional oranges were put into the box. There is the change over here. The new number of apples will become 6 times the new number of oranges in the box. And this is your after. New number of apples will become 6. New number of oranges will become 1. How many apples were there in the box at first? Okay, so let's draw out the BCA table first. Okay, you all have CA next week. That's pretty good because now you have something to help you on that. Okay, your apples, let's allocate the information first. Apples, oranges, before, change, and after. No, it's not work backwards. See, you have 4 times as many apples as there were oranges inside a box. So this 4 comes here. This 1 comes here. Okay? Then 60 apples were put in. 5 oranges were put into the box. And now your number of apples will be 6. You have 6 blocks over here, and here you would have 1 block of oranges. Okay, when we have this, you see that inside your change row, you have different numbers. Hence, all quantities would have changed. Agree? So you can't make them the same anymore. Very sad. Now in order to deal with this then, we have to use units and parts. Units for before, parts for after. Okay, then what are units and parts? Basically, units and parts, they would represent different quantities. And if you are to draw them out in a model, units probably would look like this length here, and parts would have a different length altogether. So we can say that simply that they are blocks of different lengths. And they represent different values unless you are able to prove that they are both the same thing. So over here, when we have this already, we want to list out these two statements first. We have 4 units plus 60 equals to 6 parts. 1 unit plus 5 will give us 1 part. Then over here, here's the shortcut to solving these types of problems. If not, your working can be quite long. Where is it? Okay, you see, you want to find out your number of apples in the box at first, which is apples at first, 4 units here. So to find you want to make P the same. Yeah. So these two, you want to make them the same. You want to multiply this entire statement by 6. Because when you're making something the same in this case, you want to get rid of it. You only want to leave units behind, so you have to get rid of the parts. That is the rationale for it. Okay, and a lot of times in P4 level, you all can draw out the model straight away because either the beginning or the end is already the same. But one thing that gets neglected is that your units or your parts needs to be the same first before you can draw the model. Okay? This is one part that I need to emphasize on. So when you multiply this by 6, what does it mean? It means that, okay, think of it this way. You have 1 unit and 5 over here. This gives you 1 part. When you multiply this by 6, it means that you are duplicating such that you would have 6 copies of this bar over here. And when you have this over here, you can see that everything is literally multiplied by 6. Okay? So this becomes 6 units over here. 5 times 6 will give you 30. 1 part times 6 will give you 6 parts. And when you have this, okay, if you got 60, that's the answer. When you have this, you can now draw out the two models and compare them. So let's start with this first. 4 units plus 60 is equal to 1 part. Let's start with this first. 4 units and 60 gives you 1 part. So you are done with this model here. The next one is 6 units plus 30. Now 6 units needs to be longer than 4 units by common sense reasoning. Okay, 6 units needs to be longer than 4 units. You want to add 30. Wait, sorry, this one is 6 parts. You want to add 30, and this will give you the same 6 parts as it did on top. Okay? So when we have this, here's one more thing that I always emphasize and keep on repeating in my classes. when you have done that, you want to find out the value of 1 unit. How do you do that? You want to compare your units with units, numbers with numbers. Okay? So when you do this, you will see that 6 units minus 4 units will give you 2 units here. 60 minus 30 will give you 30 over here. So 1 unit must be, if 2 units is 30, 1 unit must be 30 divided by 2 to give you 15. And when you got that, the number of apples in the box at first would have to be 4 units. So this will simply be 4 copies of 15. So the answer here would be 60 apples. Okay? Okay, first of all, you want to find out the number of apples in the box at first. So at the end of the day, it's not necessary to know what Mary had at the end. Okay? Well, all those of you who got 60, very good. How come your voice isn't synced with your mouth movements? Most probably because you're lagging. No, okay. In the end, Mary had 120. 6 units is 120. No, this is 6 parts. The parts represent a different value. Okay, when you draw the model out, it will be different. It will have a different length altogether to represent a different quantity. Okay? This part I would say minimally a P5 question. But P4 can start to do already. Okay? Yep, it's the end. Okay, thank you for joining me. So, before you leave, I have something for you. So this part can now ayo, So we're officially done with this for tonight. Okay, so here, this is what I have for you. Weekly online live classes at 10 OP for P3 to P6. So what are we doing at 10 OP? 10 OP is a platform provider for online teaching and online learning. So we at Maths Heuristics are very happy to be working with them, and we have found their platform a joy to use. So here, I would like to invite you to register for 2 trial classes, complimentary. Hang on, let me just make this a lot bigger. Yeah, we are going to have 2 trial classes that you can sign up for at this link over here. Hang on. So, for those of you who are already registered on 10OP, sorry, this one will not be valid anymore. Okay, you're welcome. Okay, the best part about this 10OP platform is that they record the lessons so that you can view it again, just like how you can view it for this Facebook Live. And by the way, okay, it's going to look somewhat like this. Let me make it bigger first. Where's the... Okay, it's going to look somewhat like this. The angle is hard to get. Okay. Can you all see it? So you all can view the replay again until you understand it. And we also have notes and solutions uploaded into this platform as well. Okay? Yeah, of course I have to block the chat in 10OP. Okay, so Desmond Yap is saying that I block the chat in 10OP. Do you know why I do that? The reason is so that you can focus on my voice and focus on the lesson instead of getting distracted by your classmates. Okay, well, welcome Jessica, welcome James. Yeah, James is asking, will there be FB Live classes in the coming weeks focusing on other topics? Yes. Okay. Of course, you only need a few jokers and the whole class will be in chaos. So of course I have to block it. Okay, you're welcome, Dahlia. Okay, welcome, Fong Yi. Welcome, Sandhya. Okay, please stop talking about BGR stuff over here. Okay, welcome, Mani. Welcome, Kendrick. Welcome, Kok Kyung. Welcome, Annie. Welcome, Melvin. Okay, so if you have any questions, I'll take them now. Okay, welcome Rekha, Faiz, Sida, Raji. And welcome Jasmine. Yeah, I will. Kendrick is saying, I hope you make more live vids. That one I will. Okay, well, you're welcome, Janet. And welcome, Sagi. Okay, so if there's no further questions, I'll take my leave first. Where's my comment? Why like that? Okay. When is the live vids? It will be on next Wednesday, 8 PM. Okay? Hi, Agnes Chong. Okay, welcome. Soon enough, you'll become a regular here. Okay, so if there's no further questions for me, I hope you've enjoyed this mini course and I hope that you are able to apply this in your daily work. If you have further questions for us, if you want further questions, additional practice, you can also come to our group, facebook.com/groups/maths-heuristics, and search for, under the tag, search for Unit transfer method. The community there has been answering pretty well. I want to thank Leslie Leong and Edwin Goh for their contributions. Okay. Okay, Ethan. Okay, Kendrick, you can ask first. Bye bye. Wow, here. Of course, there's also the maths model method that you can go to. Down there is like a treasure trove of several questions. But in our group, we have managed to filter it out because we can control it. Well, this is going to be difficult for me to remember every one of you. Okay, you're welcome, Destiny. Okay, so if there's no further questions, I'll take my leave now. Nixis, I'll definitely remember you. What do you mean by filter it out? So there are questions that in Facebook groups there's this function where you can tag the questions. For us inside our group, I have managed to tag them so far. But recently a bit overwhelmed with my new schedule, so I'll find time for it one day. I'll make time for it one day. Okay? Okay, so if there are no further questions, I'll take my leave now. Hope to see you all next week. This is Kevin from Heuristics signing off. See you all soon. Bye bye.